Alright, welcome to phase 5 of this Android app development journey. Last time we created an app that taught us how to save data. This is too much. That taught us how to save data into memory and retrieve that data. And to be specific, that kind of data was images. So that was what we dealt with last time. This time around, we are dealing with creating a fully functional app that uses an object to save values, and eventually we'll save that object to memory, to storage. So we're going to be doing this using by creating a food ordering app. So pretty much we order food items like chips, wings, and Coke, and then these details will be saved into an object class. In this case, we're going to call it a food order class. So we'll save it. We will save it into that class. Then we will place the order. So up here, we're going to have our total show here. Here we're going to have our customer's name. Here we would have every item the customer has placed. Like if they place wings, it's gonna show here. If they ordered Coke, it's gonna show here. And then this is just the button to deposit the order into the restaurant. All right. The next thing we're going to be diving into today is some basics of Java and Kotlin, depending on which one you're on. Um, and then how to use an object to work with an app, pretty much. Because in the field, in the wild, objects are very common, and that's really how you would, store values and, you know, perform computations on values that you've stored, depending on the kind of product you're working on. If you're working on an app that has to do with um, construction, you probably need an object in a class, maybe called construction class, where you would store all the tools you need, and you probably need a function in that class that will tell you which tool you need for this particular job. Um, so this is the kind of thing we're diving into today because it's going to help us know exactly how to create any kind of app just by knowing the basics of an object. So let's dive into designing this app. Okay, so we have our design. I already have this open somewhere. We have our design. Let's go into our project. So first I'm going to create a new activity. I'm going to call this screen 5 Android activity, empty activity. I'm gonna call this screen 5. Okay, and then you press finish. Okay, so I'm going to go to the XML layout of this file. So at the root we have a very basic what color is this? Blue, I mean relaxed blue, I guess. So I'm going to set that color on the constraint layout. Background color, let's see, it's always hiding from me. There you go. Okay, so bluish, let's see. Okay, yeah, that's more like it. Okay, I'm going to close this now. I'm gonna zoom in. So the first thing we have at the top is a label with some giant text. So let's dive into that. We need a text view. I'm going to make that bigger. let's see, much bigger. Okay, and it has a background that is darker than what we currently have in our roots view. So something like this. Let's see. Yeah, I think this is good. Okay. So that's done. The next thing I will do is I'll add constraints to this view. So let's do it from here. I'm going to add it on all 4 sides. Alright, then I'll drag it into place. Okay, the next thing is a text box. Edit text. So that's this one, plain text, drag it in. Let's look at the size. It has a size, okay, bit long. Okay. So next we'll add constraints. Well, actually, I should make this bigger. Let's see. View, appearance, presentation mode. Nah, this is not going to work. View, appearance. All right, so let me see if I can make this slightly bigger. This is so sensitive. Okay, go back to manual control. So I'm going to add constraints to the side. So we have it on all 4 sides now. We're going to set a background for this text view. So background, oh, it comes with default background, so I'm gonna leave that for now. But we're going to set a hint. The hint is customer name. So let's search for hint up here. Oh, hint is over here. This will be customer name. Enter. And text is none. Okay. So by the way, hint is pretty much a very faint hint of what the text box should contain. I'm sure you've seen this in online forms and apps, but this is it. Once a text is entered, the hint will disappear. Sometimes it's gonna move to the top depending on the API level of the app. So I'm going to move this to the top. Then next on our design is 3 buttons, 1 chips, 1 wings, and 1 hook. So we're going to need a button, another one, oops, and then 1 more. Okay, these are sizable buttons, so let's increase their size much more. Yeah, they should be much bigger. Okay, so increase this a little bit more. All right. One more. Okay, so the button text for this one should be chips. Um, Text chips. And the button text for this one should be, I believe, wings. Yeah, wings. And then button text for this one would be Coke. Okay. Let's increase the text size. That will be text appearance over here. Let's make it large. Same thing with this one. Text appearance large. By the way, you can actually enter specific text sizes, but if you want it to scale to different screens, using text appearance works better because it's going to pull up the attributes for text appearance for large in this case, depending on the screen size you're on. Okay, text appearance large. Okay, large. All right. Next thing is the text appearance for our text view up here. We want the text color. Where is it? Okay, let's search for it. Text color. Text color. Black. And then text appearance. We want it to be very large as well. So I'm gonna find text appearance. It's always hiding over here. Large. And then I'm gonna make that bold. Center and bold. And then one more kind of centering, which is gravity. I'm going to expand this and select center. Okay. Yeah, that looks good. I'm also going to make these button text bold. So on the text appearance, bold. Okay, then we're gonna need a label here, aka a text view, to display our ordered items. So we're going to bring in a text view down here. Let's increase the size. Oh, before we do that, or let me increase the size first, then we'll dive into that. We forgot to add constraints to our buttons. So we want this to reach the ends. Okay. Meanwhile, I'm going to add constraints. Then I'm going to drag it to the ends of the world. So I'm going to add constraints for the vertical. I've already added constraint for horizontal. Then I'll bring it down. I'm going to make the same adjustments I did for this one, except that the text is not going to be bold this time. So text appearance, I'm going to make it medium. Medium is too small. Looks like we're going to go for large again. Yeah. Text color, black. And then text alignment, we want it to be left because this is going to show like a regular writing. And then gravity, we want it to be center and left. So center, start. Yeah, there we go. I think start and left should work the same as well. So I'm gonna say center start. All right. So now we have our text view ready. I'm going to add a little margin to the left of it so that there should be margin left. Let's see, 4 dp, so that the text is not going to be touching the walls. That's why I added this margin. You can do this for anytime you want space on any side of a view. You can always use margin. There is also the option of padding, but they work the same except that margin would add space outside of the view boundaries, while padding would add space inside of the view boundaries. So that means if I wanted to add margin to this view, it's going to show, the space would appear outside of this text view. If I add padding, the space will be created inside the walls of the text view. So that's something to remember about paddings and margin. Right now, as you can see, the margin I added shows up. Let me zoom in. It zooms in so fast when I use my finger. So as you can see here, the margin I added is showing outside of the text view. Okay, I'm gonna bring this back down. All right, so let's add constraints to our buttons. Oops. I use this. Okay, I'm gonna add constraints to this one. All right, then lastly, adding constraints to this. Okay, and then we would need, we need a background for this. Over here we have bluish background, which is, where is it? Which is this hash code. I'm gonna copy the hash code and simply paste it into this text view background. On the background, I'll paste it in there. Press enter. Boom. Okay. So now I just did this. You would notice that there is a space that doesn't look natural here. So I'm gonna turn this into a padding instead for the space. So to do that, I'm going to remove the margin. Such margin. Margin. I'm going to get rid of this, and then let me make sure, this switches the walls. And then instead, I'm going to update the padding. So I'm going to say padding over here, and then I'll put that as for DP. DP is the suggested metric system. So as you can see now, the text view has a space before between the walls of the text view and the actual text. That looks good. All right. So what's remaining now is our place order button. So we're going to add a button. Then we would add constraints to our button. Okay, so I'll bring it down here and give it the name for the name is going to be place order. Okay, I'm gonna increase the height a little bit. Okay, so we have our app looking good. We have this, the food items, the log table that shows us things that we've ordered, and then the place order button. So let's take a look. Everything looks good. Except I'm going to move this up a little bit more. Bring this up and bring this one up. Okay, so it's looking good. Let's go ahead and preview this design before we start actually coding. To do that, we will go to our screen 5. Okay, no, from screen 1, and this is the XML design. We would add a button for screen 5. And then we would call this button screen 5. And this should be objects. Well, let's call it food order. Food ordering. Food order, that's fine. Food order. Okay? Screen 5, food order. And then we're going to make this button to launch our screen 5 activity. Okay, this is done. Sweet. So we need an ID for it. I'm going to copy this ID just to keep things faster, and then I'll paste it in here and modify it to 5. Okay, and then I'll go into our activity, which is main activity. I'll create a button, screen 5 button, and then I will of course initialize it, screen 5 button. This will be equal to notice the pattern of my ID naming changed somewhere there, but it's fine. Screen 5 button. Okay, then I would make the button actually click by putting a click listener on it. And to do that, we say screen 5 button dot set on click listener, new on click listener. And then I'm gonna copy the screen launching code and put it here and simply change this to screen 5. Okay, so let's go ahead and test this out and see. Looks like I need to relaunch it. Okay, I'm going to push it again. Why is it bringing me to this page? That's seed app. Okay, so food order, sweet. It brings us to this page. Looks like we have an issue with our text view here, so I'm going to go back and see what's wrong. So that will be on our screen 5. Okay, so something is wrong with our text view. Let's make it smaller and see if that fixes it. Waiting for it to load. Okay, that looks better. So I'm just going to adjust this a little bit more to fill up the space. Okay, so with this done, the app is looking good. The app is looking good. The next thing we're going to do is to now design the food order class. Remember that the goal of this app is to create a fully functional app that can actually do stuff. And like I said before, we're going to be using a class object to save these variables that we're going to be modifying, like when the user orders something. So, but before we dive into this, I want to guide you through the process of an object. That means the basics of Java and the basics of Kotlin. They're pretty much the same thing, but I'm going to focus on Java, and the code for Kotlin is here. So let's dive into that before we go into creating our own food order class. So Java 101. So we have this is a class called Java 101. A class is an object. A class is an object, but the object is the initialized version of the class. So we create a class, and then the first thing we see is an integer. In this class, this integer is a variable. Make it bigger. So the integer is here a variable, and it's called max students allowed. So this class is pretty much a class that is a classroom. So in this class we have the maximum number of students we are allowing to be in our class. And in this case is 3. This is hard coded in. The student count currently is 0, so that's why this variable is null. We have another variable called string, professor name. Oh, by the way, I forgot to mention, integers hold numbers that don't contain decimals. Strings hold texts. That's why you see I passed in a text of the professor name, which is Mr. Cool. Then we have a variable of type string list. This pretty much means that this is a type of string, but in this case it's going to contain a list. That's what this indicates. And in this case we have a list of students, Bob Wiggins, Steve Squirrel, and Crystal May. And in Java, you can initialize a list like this with commas separating the items you want to be in the list. In this case, it's a string, so I have strings separated by commas. The next thing we have in this class is the students' users name and passwords. Yes, we have them public like this for demonstration. So we have them in the form of a map. A map is a key valued pair in Java, which means it's this data structure whereby you store values in it by first passing in a key and the value. So every value has a key, which is in this case Bob, and the value is Batman. So you pass in a key and then you pass in the value. So when you want to retrieve this value, you simply pass in the key again, and then the hash map returns to you the value that corresponds to that key. So that's why here I'm saving the password of Bob, Steve, and Crystal by just calling student credentials.put, and I'm putting their credentials. So that's a hash map. It's very useful. It's very necessary to know about this in your programming journey because you're going to need it. Another cool thing about it is that it's fast. It's fast because you can just, using the key, grab values and move on. The next thing I want to show you is a double. A double is also a number, but in this case, a number that has decimals. Remember here we talked about integers. Integers do not have decimals, but doubles do have decimals. But most of the time, you probably won't be using doubles that much. It's usually integers. But when you do need to store decimal values, double is the way to go. Next, we have a string again, which is our professor's hobby, and it's hiking. So we define the string using quotes. And then lastly, in this initialization section, we have public Java 101. This function here is called a constructor. It's the constructor that initializes the class when you load an object. So it's always required depending on the nature of the class. So here in our constructor, we have a parameter called student count. So this is where the school admin would set up how many students they want to be in a class, or they want the class to contain. So when initializing this class loads the student count variable, which is this one up here. It loads it with the actual student count passed in the parameter of this Java 101 constructor. So that's where it goes, and then the next thing after this is a function again. Remember, this is a constructor and this is a function. The major difference is that this one in Java, it's going to carry the same name as the class. Java 101 class name is Java 101. That's how you know constructors. Okay. Then next we have a function that says get first student's name, which returns the first student in the list. So here we are playing around with lists. The function says get first student name. To do that, querying the we are querying the list of student name list, which is this list we have up here, and passing in the index of 0 as the preferred index, because that's where the first student is going to be located. In programming, the first index in any list is usually 0. So that's why here we're using 0 to get the first student's name. And while getting this name, we use the square brackets and then passing the index. That's how we grab an index value from a list. Next thing I want to show you is the concept of getting the size of a list. And we do that by saying dot length on a list. This could also be dot size depending on the kind of data you're dealing with, but here dot length works. So this will give us the length of the students in this, the number of students in this class. Actually, I'm going to change this to dot size later. Broadcast announcements. This is a function that broadcasts an announcement in the class, and in this case we're going to print it to the command line by using to the terminal using system.out.println. This is how we do it in Java. Then there is a function called isClassFull, and then this function checks the maximum students allowed using a greater than or equal to operator, and then based on that it's going to set this variable to true or false depending on whether the class list is greater than the class list size is greater than the maximum students allowed. The next thing I want to show you is the basics of operators in Java, or in most languages also. So whenever you see these two straight lines, it means or. That's the same or you know in English. You know, apple or oranges, bacon or beef. You know, that's what you use for or in Java. And the double and also means and. So wherever you see this, it means and in Java. All right, so let's play around and test this out. So what do you think this is going to equate to? Is it true or false? So we have if 2 is greater than 1 and 4 is less than 6. Do this, whatever is inside this parenthesis. Okay, so this is going to equate to true because 2 is greater than 1 and 4 is less than 6. So this will equate to true. Here is another approach to it. If true or true and false or false, what do you think this would output to? This should output to true because it's going to be or, and this would be and inside there we have another or. All right, so this is a very fast demo of how this and or works. Another sample is here. The main difference here is that I'm boxing them in parentheses to make them more readable. So if true or true, or if false or false. The major difference is that here they're in parentheses, which is a recommended pattern because it makes the code much more readable. But the computer would always understand. But putting them in parentheses like this would make them much more pleasant to understand. Okay, let's take a look at the Kotlin version of this. It's pretty much the same thing, just different syntaxing. Okay, let me zoom in a little bit. All right, so Kotlin. By the way, if you are focused on Java, don't pay too much attention to this Kotlin part. I'm just gonna breeze through it. So it's the same thing we just did for Java. The major difference is that um, the constructor comes with init, and then the parameters of the constructor comes up here in the class. And then there are slightly different ways of initializing a list. In Kotlin, array list of, hash map of. Um, but aside from that, everything is pretty much the same with what I just explained for the Java. Just that if you focus on Kotlin, you should understand this methods. So another thing I want to say is this class is a very nice reference for Kotlin or Java in this case. It's good to keep this class in your arsenal of tools so that when you need some kind of review, you can come back here and see how a class is created, how a class can have a parameter, how a class can be initialized, and all those good stuff. So this is Kotlin and this is Java. So using this concept here, I'm going to create our own food order class now. Okay. All right, so let's dive in. Okay, so under our utils folder, we're going to create a class and call it food order. Okay, so in here, the first thing we are going to have, or we should have, is our order ID. So we're going to say string order ID. I'm not going to initialize this now. And then the next thing we should have is the items that the user has ordered: bacon, egg, ham, everything. So I'm going to create an array list of string to save the things the user has ordered. So string, these are all Java basics. So I'm also not going to initialize this yet. Then next will be our customer name, which will be a string again, customer name. And then lastly will be the total items the user has ordered, the customer has ordered. Total cost of everything. Okay. And then one more is a hash map that is going to contain the prices mapped to the items we have on the menu for today. So we're going to say hash map you know what, let me make things faster and copy the one we already have. So here we have let's see, Java basics. So I'm going to copy this hash map here and then just modify it in our food order. Okay, so hash map, I'm going to call this price dict. That means a price dictionary of things we have in our menu. Okay, and then this will be wings. Remember we have chips, wings, and Coke. So this will be wings. Wings. And the value would be an integer price of $1. And that also reminds me, I need to change this to integer. Okay, because it's a map of string mapped to numbers. And this also reminds me, when you are passing in an integer type, you usually want, as a parameter or in an initialization line like this, you always want to use the object version of integer. This is generic, this is the object version. This, if I pass in the generic one here, it's not going to work. We always need the object version of integers. So back to putting stuff in our map. So wings, chips, and then here we're going to have the price, which will be $2, and then here we would have drinks, let's make this lowercase, and then the price will be $3. Okay. All right. So now we have our price dictionary of foods. The next thing we're going to deal with is the constructor of this class. Remember, I told you constructors come with the name of the class. So this will be public food order. And we only need one parameter for the constructor, which would be the customer name. I'm just going to leave it as customer. All right, and then I'm going to say this dot customer name. This code right here in green is pointing to my customer name up here. That's why I'm putting this, so that the code knows that I'm talking about the variable in this class. Sometimes the parameter would match the name here. So to avoid confusion, we use this to force the compiler to know we're referring to this variable here. So this dot customer name equals to customer name, which is the one I have in my parameter. So that one is initialized. The next thing we're going to do is set up our order ID. And this will be equal to, we need a random string. Now, to generate a random string, I have a snippet of code for you in the document. This one, so I'm going to copy this object. So I'm going to paste it inside my tools. Remember, you should have this file. So I'm going to paste it in here. I'm going to import the necessary stuff. We have an error. What is this for? Oh, I put the function in another function. Can you imagine that? Okay. So this is a function. All right. So here we have our get random string function, and it's ready to return random strings. So we're going to use this straight away in our food order class. We're going to say tools dot get random string. I'm going to pass in 8, so that way I get a string long enough to be unique. Sometimes even 4 random strings are enough, but depending on the scale of your app. All right. So the next thing we're going to do is to create a function. To initialize our list as well, our items list. Yes, we have to initialize everything, because otherwise they currently have a default value of null. So if you use them like this, the app is going to crash because they don't have the value. So that's why I'm going to initialize this now as new array list. What else do I have to initialize? Food order, customer name, total costs. I'm going to initialize that as 0 for now. Total costs equal to 0. Right? So the next thing I'm going to do is create the function that is actually now going to add food items to this class. So remember, this is a food order object, and we probably want to add food items to our food order. So to do that, I'm going to create a function, public void add food item, string food item. Okay. So now let's get to work and actually code and show you what I mean by an object that has functions that does stuff with the variables in the class. So remember that the goal is that when a button is clicked, it's going to call the function in our food order class. It's going to call the function add food item. And when that is done, it's going to display the total up here, the new total. Okay, so let's go back. So the first thing we're going to do is make sure that our food item passed in is in lowercase, just like this one, because in programming, uppercase and lowercase are not the same thing. If you put uppercase W here and use lowercase w to try to access it, it's not going to work because they're different characters. All right, so we're going to have string my food item equal to food item dot to lowercase. Okay. So the next thing we're going to do here now is to create an if statement that would use this name as a key to grab the necessary stuff and then to display the order item on this list here. All right, so let's go ahead with that if statement. If price dictionary, remember this, dot key set. Key set is the keys we have in our dictionary. Here we're checking if this food item is actually on the menu. Dot contains, and here we pass in the food item, my food item. So if it's contained in our menu, we would add it to our items. So this is where we say items, dot add. Let me scroll up. And then we add our food item. Next, we update the price, the total cost of our food so far. We do that by saying int price equal to, so we get the price, that is the price of this food item. Get the price by saying price dictionary dot get my food item. Then we add this new price to the total cost we already have here, the total sum of items on this order. So to do that, we say total cost equal to total cost plus price. So if the food item is on our menu, that's why we're saying if price dictionary dot key set dot contains my food item, then we grab the food item confidently and then use that value of its price to update our text view. So let's do that. But first we need an else statement in case the food item is not available. So this is how you print system.out.println. Sorry, item is not available. Okay, sorry, item is not available. All right, so right now we've just created a whole food order class with the order ID, items, customer name, and total cost. And of course, the price dictionary. So with this done, we can now go straight into the app and make these buttons actually do stuff using this class. Okay? All right. But before we dive into that, we still need to create a restaurant class. Remember, we just created a food order class. We still need a restaurant class because in a restaurant, in the morning, we can have 10 customers. Each of them would create a food order. But we need somewhere to store all that food order and let that be a restaurant, a grand restaurant. Okay? So, how do we create a restaurant and then store food orders in it? It's pretty simple if you think about it. We create a new class called restaurant, and then in there we would have a hash map of the customer's name and the food they ordered. So that means we're going to be using our food order class as a mini object actually that is going to be stored in another grander, bigger object. Kind of. All right, so let's dive in. So a restaurant class. Let's create a file called restaurant, new Java class. We're going to call this restaurant. So the restaurant class is going to be pretty much simple because it's not going to be as complex as the food order. It's just going to be it's very straightforward, hash map that will contain our food orders. So to do that, let's first of all create some kind of ID for a restaurant and let the ID be our manager name. So we're going to create a string and call it manager name, and then we'll create the hash map, and this hash map is going to contain a string as key, comma, and then a food order as the value, and we're going to call this food orders. So this will be a hash map of, aka dictionary of, customer name and customer order objects. This is just a note. All right. So the next thing we're going to need here is a constructor for our class, which will go as public. Remember, a constructor goes with the name of the class. So public restaurant, and this constructor needs a parameter for a manager name, because when you create a restaurant, you probably want a manager. So we're going to be initializing this with a manager name. We're going to call this manager name. So in this constructor, we would initialize the manager name with the one passed in as a parameter here. So this dot manager name means is pointing to this one. We're going to equate this to the manager name passed in as a parameter. So I'm just going to say manager name. And this one is pointing to this one. Then lastly, we're going to say food orders equal to new hash map so our food order is initialized. So we have our restaurants. Inside there we have two main variables, which is a manager name and then a hash map of food orders. Pretty much this. We have our restaurant, and inside there we have a manager name and then a list of orders that we can access using the key. In this case will be the names of the customers that place the orders. All right. In the modern day, they usually use phone numbers, but to keep things simple, we're just gonna use the name of the customer. All right. So food order is done. Restaurant is done, and food order class is done. Now we'll dive into the Java code. We've designed the app interface. We've gone through the basics of Java and Kotlin. We've created a food order class. We've added the random string code. We've created a restaurant class. So now it's time to stitch everything together in an activity. Let's dive in. So screen 5. All right, so it looks like we need to go create IDs for our view. So here we have a text view. Let's call this some text view. Some text view. Okay. We're going to give this one an ID of customer name. Oops, I made a mistake. So on this text view under ID, we're gonna ID it as some text view, and then for the customer name text box, we're going to ID this one as customer name text box. And then for the chips, we're going to call it chips button. For this one, we're going to call it wings button. And for this one, we're going to call it Coke button. And then down here we have our text view, which will be our orders screen. Let's call it orders screen. This is a text view though. And then this one will be place order button. So place order button. BTN. Okay. So we have everything ID'd. Now we can use all these IDs in our class. So this one is some text view. I'm going to copy it to make things faster. I'm going to go to screen 5. So I'm going to create a text view. Remember, text view. I'm going to call it some. Let's call it some TV. Some TV. And then we would add an ID for it. So some TV, this will be equal to find view by ID, r.id dot the ID we created. Then next we have our screen 5. Next we have our customer name text box. I'm going to copy that ID. So in the Java class, we would say we will create that variable, that object, which will be edit text. That's a text box, and we'll call it customer name TB as text box. Okay, and then here we would say customer name text box equal to find view by ID, r.id dot customer name text box. So next thing is the 3 buttons, chips, wings, and Coke. So we're going to go create those 3 buttons and then add their IDs. So button, chips, button, comma, Coke, button, comma, and wings, button, semicolon. And this should be lowercase. In programming, it's always good to make sure that the name of variables start with lowercase. But when you're creating the class, of course, it should be an uppercase letter. So let's define these. Let's initialize them. So chips button is equal to find view by ID, r.id.chips button. And then our Coke button will be equal to find view by ID, r.id.Coke button. And then our wings button will be equal to find view by ID, r.id.wings button. So before we move further, let me make sure everything is correct. Wings, Coke, chips, customer name TB, customer name text box. Awesome. So the next thing we have to initialize is our, where is my screen 5? Awesome. Our text view that shows the ordered items. I'm gonna click that. The ID is orders screen. I'm going to copy this. Screen 5. So we're going to add another text view. I'm simply going to use a comma to keep things, to show you a different way of doing it. So comma, orders, let's call it TV, orders TV. Okay, so orders TV would be orders TV equal to find view by ID, r.id.orders screen. Yeah, orders screen. Then lastly is our place order button. Place order button. And then I'm going to put it here to be together with other buttons. So that would be place other button equal to find view by ID r.id dot place order button. Okay, everything is looking good. Screen 5. So we have initialize this, and this. Looks like we are ready to connect these and start making them functional. So again, the goal of our app is that when we click a button, we add an item to our list of orders, to our list of ordered items in our food order class. So let's go ahead and initialize a grand food order and a grand restaurant. Pretty much we are creating a brand new restaurant, and then we are creating a fake order. So let's first of all create the restaurant. So oops, wrong place. So I'm going to create the restaurant variable, restaurants. Let's call it restaurant. Or let's give it a more unique name. Let's say downtown restaurant. That's a long name, but you get it. Usually I don't like long names, but just trying to make this understandable. So downtown restaurant, downtown restaurant equal to new restaurant, and we pass in the manager name. In this case, we're going to use a manager name of whose manager name are we gonna use? Let's see. How about Steve? Let's say Steve. Okay, so Steve is the owner of the restaurant, and then we need a food order, a fake one. So let's create a variable and call it order, food order. Let's call it order. Okay, and we initialize it here by saying order equal to our first customer of the day, which happens to be Mary. This is all fake. So food order and food order has, is this an O? I think, let me make sure. Food order, yeah, it's an O. Okay, all right. Food order, sorry, new food order. Thank you. New food order, and then we pass in the name of our first customer, which happens to be Mary. Of course, I made this up. And then we have a restaurant now, and then we have a variable, a new food order from Mary. So in this object here, we're going to modify every order that Mary makes, and then update our sum TV. In this case, our display. Where is our? In this case, our sum with the sum of the orders Mary made, and then the orders down here. I need to make this to be 0. Let's go ahead and do that. Screen 5. So the text should be 0. $0. $0. Okay, let's go back. Okay, so let's create the function that is going to handle the clicks. In this case, that would be public void sets click listeners. I'm going to call that function immediately here, set click listeners. Okay, then it's in here. I'm going to now set up my buttons. I'm going to say the first button we have is our chips button. So chips button dot set on click listener, new on click listener. I'm going to do the same thing for our wings button and for our drinks button. So let's change this to wings, and then I'm gonna change this one to drinks. Wait, what did I call that? Chips, Coke. Okay, Coke button. Okay, sweet. So next, we're going to make this button do stuff. So the number one thing we want to do when a chip button is clicked is that we want it to add chips to this person's order. So remember we created a class, a function that does this for us. That's what this is. So instead of having this whole code in our activity class, we created this function in the food order to make it simple. So we're just gonna call this function and then the order will be added. It's really that simple. So screen 5. Screen 5, so when the chips button is clicked, when this button is clicked, we want to say order dot add food item chips. Okay, before I proceed, let me make sure this chips matches the name I gave it in the food order class. Yes, it matches it correctly. Okay, so order dot add food item chips. So when the wings button is clicked, I want to do the same thing as well. So order dot add food item. In this case, I'm going to say wings. All right, and I'll do the same thing for the Coke button. Order dot add food item. In this case, we're going to add drink. I believe that's what we called it, drink. Let's see, food order class. Yeah, we called it drinks. Okay. Should this be drinks or drink? I'm gonna leave it as. Let me make it drink. Yeah, let's leave it as drink. All right, so I'm gonna come back here. Screen 5, drink. Okay. So order dot add food item drink. All right. So now this is done. Let's run the app and test. All right. Okay, so chips, wings, Coke. Notice nothing is happening visually. That's because we haven't written the code for updating this text view and this one when something is clicked. This should be Mary. All right, so let's dive in and make this work. Let's update this sum total when these buttons are clicked. All right, so let's dive in. So after the order is added, we need to set up the text. So on some TV, we would say some TV dot set text, and we want this text to be order dot sum, right? What did we call it? Let's check. Total cost. Okay, total cost. So order dot total cost, and then we're gonna make this a string by adding quotes. All right, why is this in red? Okay, so I forgot to put a modifier of public on these. That's what's gonna allow it to be visible outside here. So I'm going to make this public. This would make it visible outside. Public, what else do we need to, this should be public as well. Public. The public modifier makes it visible when initialized as a class. Otherwise, it's only going to be visible in this editing space. I mean, visible to be called, to be used. But this public is gonna make it show up on screen 5 now. What else do we need to make public? This should be public as well. Public items. Everything here needs to be public actually. Okay, and then the price dictionary public. Okay, so let's go back. So order dot, let me make this bigger. View appearance. View. Okay, so order dot total cost plus quotes. So this would allow us to see the total cost after the order is placed. Okay, I'm gonna do the same thing here, and then I'm going to do the same thing here as well. Now the next thing is remember we have a label at the bottom here, a text view that is supposed to be showing it's supposed to be showing the items we've placed order for. All right, so let's go ahead and use this and display the text as well on those items. So first thing we're going to do is going to say string. We're going to grab the list of orders first. String let's call it ordered items equal to order, and as you might have guessed, we're going to reference, we're going to, let me exit here first, appearance, exit presentation mode. We're going to reference this list we have here and then turn this into a string and display it. All right, I wish this thing had a shortcut. Anyways, so order dot items dot toString. Okay, and then we're going to display this in our text view. So what did we call that text view again? Up here we called it orders TV. Oh, by the way, let me make orders TV to a blank from here, orders TV equals orders TV dot set text empty text. All right. So going back here in our buttons, so we now display the ordered items on our orders TV. So we say orders TV dot set text, and then we pass in the ordered items returned into a string here. So we say ordered items. So we do the same thing for every other button. Okay. I think it's a good time to test. So let's go test and see. So we have our four main things. We have our order placed, and we have our order added to the list. We updated the sum of the new total cost. We grabbed the list of orders of items the user has ordered, turned it into a string, and passed it into our orders TV screen. So let's test this app and see how it's working so far. Okay, so chips, okay, wings, Coke, chips, wings, Coke, looking good. Chips, wings and wings, Coke. Okay. One thing I noticed is that we have this parentheses here that probably shouldn't be there, and then we're missing the dollar sign. I'm going to show you how to get rid of this parentheses, just so you know how it's done. So in our code, we're going to add a dollar sign. So dollar sign should be here. Quotes, dollar sign. And then I'm going to put a plus to join the text. And then for this list, I'm also going to remove that bracket. I'm going to say dot replace. So in this case, I'm replacing this with an empty string. All right, and then I'm also going to do the same thing for the ending parenthesis, the closing one, but in this case it's gonna be this. Okay, so let's run the app again and test. I'm gonna copy this. Okay, let's see how this works out. Okay, chips. We have the dollar sign there, looking good. Wings, wings. Coke, Coke, looking good. And as you can also see, the parenthesis is gone now. Let me do it again so you can see. Chips, you see there is no more parenthesis. Wings, Coke, looking good, looking very good. Looking very good. So the only thing remaining now is saving this. How do we save this into memory and into our restaurant class? So first, let's start with saving this into our restaurant class. Remember that in our restaurant class, we have where is it? Restaurant. So in our restaurant class, we have one major variable here, which is our food orders plural hash map. So we can save into our food orders hash map by passing in a customer's name and then the food order. So in our screen 5, we have our food order variable up here, which we've initialized with Mary, a customer called Mary. So we just need to pass in this order into our restaurant, which we've also initialized as, downtown restaurant. That's the name of the restaurant. So let's do this. So when the save button is clicked, place order button. When the place order button is clicked, place order button dot set on click listener, new on click listener. So when this is done, we would say downtown restaurant. Oh my god, downtown restaurants dot our hash map is not showing up, so I need to go back and make this public on this one to public so we can see it. Awesome. Okay, so the downtown restaurant dot food orders dot puts, in this case I'll pass in the key, and I want the key to be the customer's name, and in this case the customer's name is, let me make this bigger. In this case, the customer's name is Mary. So I'm going to copy this, scroll all the way down. So downtown restaurant.foodorders.puts Mary, comma, the value will be order, which is order that we'll be modifying throughout today. All right. If you are on Kotlin, this is pretty much the same process. I don't think anything I've been doing today is majorly different. It's really the same thing. The only thing is just the food order class and the restaurant class you have to write in Kotlin. But guess what? Even if it's written in Java, it's still gonna work with Kotlin because they work hand in hand. So pretty much everything should be the same on your Kotlin side. So downtown restaurant.foodorders.puts this. So guess what? Now we still need to save this into storage, and to do that we can now use tinydb to save it into storage. Tinydb equal to new tinydb, pass in the context of the app, get application context, and then we can now use tinydb to save this. Tinydb dot puts objects. We want to put an object, puts object, and then we pass in a key for our object. Now this is not a map exactly, but this is a key that we're going to use to retrieve this object of restaurants in the future. So like I said earlier, in programming we deal with a lot of key value pairs. So for now we're saving our restaurant into storage. So we'll say tinydb.put objects, and then we'll say the key. Let's give it a key of my restaurant, and then a value of the restaurant, which is our downtown restaurant. So downtown restaurant. Okay, and when this is done, it's proper to toast to the user tools.toast and tell them that, hey, your order has been saved. That way they know that tools.toast. So we let them know that their order has been placed. Order placed. Comma, and then we pass in the context, I believe. Get application context. So this should work. Just to add a little cherry on top of this, let's find the smiley emoji and put it in here. So let's go to our web browser. Smiley emoji. Okay. Let's copy this. And then go back to our code, put it in here. Yes, this is the Unicode for the emoji. So in the place order button, we place the food order into our restaurant. That's one, by saving it using the customer's name, and then we use tinydb to save this restaurant object into memory. Then last, we toast the message to the user telling them that their order has been placed. Okay, so let's test that out and see how it looks. Okay, so 2 chips, 2 wings, 1 Coke. Of course, maybe Mary. All right, then we place an order. You see, order placed. You see the emoji. Now, one thing we didn't get to is using this text box to assign a customer name. But this can be done very easily by simply saying, I didn't do it just to keep things simple and straight to the point, but we can grab the customer name from the text box by saying something like, where is it? By saying something like string customer name, which will be equal to customer name text box dot get text dot toString. That's how we grab the text from the text box. Then we can use it anywhere. We can even use it as a key, or we can even pass it into the order dot customer name, and we can call it, let's call to customer name. So this is how we can actually use this text box. Okay. The next thing, did we get through everything? Okay, so imagine in the next time this app is loaded, you want you want to load it into a screen of the restaurant where you have all these orders that you need to deal with. Um, so how do you imagine we had another screen of restaurants that had all these orders? So how do you load up the restaurant again? It's really simple. Simply use TinyDB to I'm pretty much using this as a scratch pad right now, but pretty much use TinyDB in the beginning of the onCreate. So instead of saying new restaurant, you probably would say something like if at this point I'm going to make TinyDB a global variable to keep things simple. TinyDB TinyDB, and then I'm gonna need a context object, context C. So I'm going to say I'm gonna initialize it here. Context no C equal to get application context, then TinyDB equal to new TinyDB C. That's the context. All right. Okay. So if TinyDB dot get dot object exists, I believe we have an object exists function in there, don't we? Okay, let's do it another way. So if TinyDB dot get string and then we pass in the key of the object, because ultimately those objects are saved as strings. So if TinyDB.getString, then we pass in the name of the object. Where is it? This is the key we used. So if TinyDB.getString, my restaurant dot is empty, then we know that the restaurant has never been saved to memory. Else so if TinyDB, if there is no restaurant in memory, we would create a brand new restaurant. Otherwise, we would load restaurant from memory by saying TinyDB dot get object, and then we pass in the restaurant name, into the restaurant object, restaurant downtown restaurant equal to TinyDB.get object restaurants, and then we pass in the object type. So restaurants dot class. Okay, so this is how we retrieve the object from memory. If TinyDB, by the way, by the time you go through this tutorial, there will be a function called object exists, so you can use that instead as a boolean check instead of this long method. But anyways, if TinyDB.getString, my restaurant exists, is empty, then we know that restaurant does not exist, so we create a brand new one. Otherwise, we say TinyDB.getObject from memory, and then we load it into our restaurant. So that way this is how we load our objects from memory. Um, so with that covered, let's see. So we've created a fully functional app. We've designed the app interface. We've gone through the basics of Java and Kotlin. We've created a food order class, and we initialized that class using an ID, which in this case was the customer's name. We've created the restaurant. Um, we've stitched everything together to get a working app. And then we've gone over how objects work. Oh, speaking of objects and JSON, so what we just did, what we just did with food order, this is a class, okay? And when you initialize a class, it's an object that you manipulate. That's what we did. That's what we did here with food order. So now this is an object, and this one is a class, okay? So now we have this object. When we save the object into memory using TinyDB, what we are basically doing is this, where is it? What we're basically doing is this put object method. It's converting our restaurant into a string. So right now our restaurant is an object. When we are saving it into memory, it's converting it into a string, like a plain text string, and then saving that string into memory the regular way. The special thing I want you to know here is that when in programming, when you convert an object into a string, that object is now in the form of what is called JSON. Okay, let me show you. So this is the code that puts the object, as you can see, converts it into JSON and then saves it as a string. So in programming, JSON is used a lot. When you get objects from memory, they are loaded as JSON. When you put objects into memory, they are also stored as JSON. So when you are loading a restaurant, it's loaded up from a JSON string and then converted back into an actual restaurant object. So keep this in mind because you're going to come across JSON a lot in programming. It's going to be one of those things that you have to know. So that's classes, objects, and JSON. For your homework, please remember to keep learning Java or Kotlin, depending on which one you want. But keep practicing. Code Academy has a very good outlay of a way to learn these programming languages. In the next session, we're going to be diving into the Internet of Things. We're going to be creating an app that stores stuff on the net, retrieves stuff on the net. Is really going to be cool. So, prepare. It's going to be a very fun session on the next one. With that said, you can go ahead and start imagining how you can create an app for your restaurant because we've done it and now you know how to do it. Okay. Oh, one last thing. Imagine we want to close this screen after this button is clicked. It's very simple. To do that, simply call the code finish. Let me show you. I'm gonna get rid of this. Simply call finish. This would close your activity. All right. So let me show you. So imagine you placed some orders and then you click place order. The order is placed and then the activity closes. That's what finish does. It closes the activity for you. So if I do something similar so if I call finish on this activity, is going to close this remaining activity, which means the app would close in general. So that's how you close an app. And with that said, I will close this video.